Hey everyone, welcome to Office Hours with Cloud Posse, where we discuss the latest DevOps news, AWS announcements, and Terraform insights, all sourced from our sweetops community, plus a live Q&A you can't find anywhere else. It's October 15th, 2025. I'm your host, Eric Osterman. Real quick, I'm the founder and CEO of Cloud Posse. Cloud Posse sells AWS reference architectures that get you production ready in just 2 weeks. So if that sounds interesting, head over to cloudposse.com to learn more. Now, how can you maximize today's session? Our format is very informal. Engage as much as you'd like, ask questions, and if you're curious about any of our open source tools like Atmos, this is a great place to ask. For those on the recording, we host these calls live, so don't miss out. You can join us live by going to cloudposse.com/officehours. I do have one ask. If you find any portion of today's office hours session valuable, share it with your team. Just head over to youtube.com/cloudposse, where you'll find the recording posted in a couple hours. So today we do have a special format. We're going to go over the current events as we usually do, followed by a demo of Atmos Auth, which is a new feature we announced last week. Atmos Auth is a great way to simplify authentication with multiple cloud providers using your current IDP, SAML, OIDC, all of that, without having the need to string together dozens of other tools. It handles all of that just in the Atmos CLI. So if that sounds interesting, make sure you stick around for that portion of today's show. So with that said, let's get started discussing the current events. First is a small one. With any coming of age of a platform, there comes a time when certain things need to be deprecated. A recent example of this is Opsgenie. Opsgenie is going to be shut down. Well, actually, I think it's not until April 2027 or so, but they're not accepting new signups, and it's not something we're going to continue to support. So we wanted to do a formal deprecation, follow a formal deprecation process of that. So we wrote up a post on it. Looking for comments. If anyone has any feedback on it, we'll share this link in the Zoom chat. Feel free to leave comments if there's something unclear with our deprecation process. We have hundreds of modules, hundreds of components, and at some point, some just don't work anymore. So check it out. Any questions on the deprecation? I know you haven't had a chance to read it yet, but overall concerns or questions regarding that? All right. Well, I guess I could say just an outline of it. The deprecation process is roughly, we will announce any deprecation of a component before deprecating it by adding an admonition to the component, signaling that this is slated for deprecation. Separately, we will create a GitHub issue announcing that we will pin in the repository. That allows for conversation regarding a proposed deprecation. And then at a given date, the repository will be archived. And that's basically what this spells out. All right. Next, so one of the things we've been doing at Cloud Posse for the last few weeks is working on performance profiling Atmos and improving the performance. If you're not familiar with Atmos, Atmos is our framework for our cloud infrastructure. It supports Terraform, it supports OpenTofu, Packer, Helm file, and more component types are slated to come out down the road. And the interesting thing with a problem solution cycle is that with every problem you solve, there's a new problem that results in solving that. So if you're working with Terraform at any sort of scale, one of the first things you'll encounter is that your Terraform state becomes too large. The blast radius is too massive. If you have multiple teams working on that same Terraform root module, modifying that graph at the same time, you're going to run into problems. It's a compliance nightmare, etc. So you break that infrastructure into smaller pieces. And then how do you solve it? Because Terraform doesn't solve how you manage your infrastructure in smaller pieces. Well, you need to do some extra tooling. There are other solutions out there. Our solution for that is Atmos. Atmos is this framework that solves it. Well, The new problem is we have customers that have thousands, if not tens of thousands of Terraform root module instances where the in-memory YAML would serialize to hundreds of thousands of lines. And it was just not something we had to solve before. But now that we have customers at that scale, we have to solve it. So the cool thing is that we implemented profiling natively in Atmos, which is more of a nerd feature, not something everyone will need to take advantage of. I guess it's under Atmos tools, learn, troubleshooting, where was it? Troubleshoot, performance profiling. So we talk about the performance profiling feature here in Atmos, which works both with pprof and also a built-in profiler in Atmos to show you where the slowdown is inside of Atmos. Serializing, deserializing the YAML, evaluating functions, merging configurations, etc. And well, that's great. Solves a new problem. I believe Andre on our team has come up with a 4x improvement that'll be coming out very shortly as a result of this profiling data. But now we have a new problem. What is all this profiling data good for if we're not tracking it over time so we catch those regressions? One of the things that's worked really well for us at Cloud Posse is introducing Codecov. And Codecov, in all fairness, is free for open source projects, so that makes it a lot more exciting for me. We pay a lot in SaaS already. But with code coverage, what we can do is we can track that every pull request raises the bar. So we never allow regressions in test coverage. And the only way that's really practical is if some tool is tracking that. And Codecov is one of those tools that does that, and it's been really good at it. But now that we added profiling, how do we track regressions in performance? And turns out Codecov can't do that. So I was doing some research and I came across a tool called Benchy. I think it was .dev. No, that wasn't that. I should use my notes. Good thing nobody trolled me on that one. Bencher, not Benchy, Bencher, which is similar to Codecov, but for performance profiling. It's free for open source projects as well. There's a GitHub action you can add to your project. We haven't tested it out yet. I was kind of curious, since this is a new area for us in performance profiling, if there's other mainstream solutions like Codecov that you've come across. I'd like to be aware of those. And this works with all the major languages and frameworks. It works with the dash benchmark flag in Go, which is used for profiling. And this will then let you see your performance over time. And looks like their graph here isn't loading. So a nice one somewhere, but yeah. Oh well, they missed their 15 minutes of fame. Any benchmarking, profiling solutions that you guys recommend we check out to understand regressions in specifically Go test benchmark performance? All right. Huh. Yeah. All right. Next topic, Jetski. So one of the things that's come up now more than once on our office hours when you're working with MCPs is the absence of any semblance of security for these MCPs themselves. And what are they doing? What are they like? What are the prompts flowing through these MCPs? What about the credentials required for that MCP to access your cloud provider like AWS or GitHub and so forth. What happens if there's a supply chain attack that kind of looks for those credentials and leaks those? All those things keep me up at night. I'm not saying this is the answer, but I saw this when I was watching another video. Somebody was showing how they were working with MCPs, and this caught my attention. So Jetski is an open source like proxy that runs your MCP servers and gives you visibility into all the prompts flowing through it, so you can actually see what data is going there, and it supposedly handles the authentication piece of it. That's all I know right now. Curious if anybody's heard of Jetski or looked into it. Pretty new project. All right. Next announcement was something that Dan shared on our team. I thought this was pretty cool that supposedly now on GitHub, if you have access to Copilot, you should be able to now prompt your way into creating a net new repository. For me, for whatever reason, when I go to GitHub, even though I pay for Copilot, I don't have access to this feature when I go to like Cloud Posse, new, start with a template. Yeah, I don't see this option, but it works for other members of our team, I think.
Maybe it's one of those opt-in preview features.
That could be it. Yeah.
Yeah, I think I've opted in into all the Copilot features.
Oh.
So I see those also for like suggesting Copilot PRs
Hmm.
like directly in line for a file.
Yeah, that was also really cool. You were telling us about that feature. See, Copilot,
Yeah.
GitHub Copilot opt-in.
I was gonna say I noticed on my GitHub, I actually see in the top right near the search bar, I see a Copilot button for something, but also an agents panel. So I can actually right to the left of your plus button for a new repository.
Right to the left. Oh, here you see
Yeah.
some.
I see a little double panel with
Huh.
an agents panel and a Copilot.
Huh. Yeah,
Interesting.
so it's just like it's not enabled for my session at all.
It looks like it's kind of like their in web browser, maybe almost conductor-esque.
Mhm.
You just tell it to target a repository and start writing something. Interesting. I'll have to check that out.
Copilot in GitHub. Oh, there we go. Maybe that was it.
There's an opt-in for features there.
Yeah.
Another.
Okay, now suddenly it's all unlocking for me. This is why I have office hours. All right.
Oh, which page is this? Could you drop a link to it in the chat?
Yeah, yeah. So substitute obviously your
Yeah.
organization for this, but where's my chat?
I've noticed extremely helpful. If you edit a file in the GitHub UI, you can have it auto create the commit message, the PR title, and then once the PR is ready to go, you can actually have it generate the description too. And you can have it, uh, you can essentially comment on a line of code in a repository from the UI and have the Copilot start programming a fix for it. So like in
That's
Terraform, if it's like this is missing, a description for our required description on variables, it'll go ahead and add one, create the PR title, description, all that stuff. It's pretty helpful.
Well, let's test it out right now. So now I got that menu you're talking about right here for the agent task. So that's cool. That's promising. Now I bet if I go back to here and go to new, I should see the prompt ability. Yep, jumpstart your project with a prompt. Very cool. Now it'd be really cool if our organization could have prompts, like create a new Terraform repository following these. Like there should be a prompt library associated with this. That would be super cool. All right, now let's see if we can test that feature you're talking about. So if we go to RDS proxy, let's look at variables. So like here, how do I use that feature you're talking about, Ben?
Click on line 42, and then yeah, on the right
Oh,
now
there we
you
go.
have that, and you
Yeah,
can say suggest improve. Well, actually, that's probably an auto like. How would I improve this? But you could say new
yeah,
agent task and say add a
yeah.
period to the end of this or something.
Show, add to the description an example of the auth structure. Yeah. Now GitHub should just buy, I guess, Quad code, and then all our problems go away. All right. I heard there's some what was it? Memorandum at Microsoft saying that they got to stop using everybody else's AI coding tools and they need to start using their own, which makes a lot of sense, right? That you won't know the pain or problems you have in your own tools unless you use them yourself. All right, so that's cool. Let's see what happens with that. I don't know what happened. It just disappeared when I was there. I didn't even see it.
I think I know what happens. We actually experienced this. We have Mergify working against us here. If you go to closed PRs,
Oh, really?
yeah, Mergify will close it if there's no changes or an empty commit. And so actually, this is one little hiccup with the two AIs, or maybe not AI, but Mergify is saying there's nothing to change, so we're gonna close it. And then that'll actually shut down Copilot saying, uh, you know,
Oh,
if the
okay.
PR is closed, I'm done. So because you probably
Yeah,
don't need
yeah,
the
yeah, yeah.
PR.
Well, we can fix that.
Yeah.
If you just
So, but it's
manually reopen it, and Copilot will continue.
oh, really? Okay.
But if I might have deleted the branch.
But no, that's interesting though. We should fix that in our Mergify configuration to ignore the Copilot bot user. But it's also interesting to me from a pull request workflow perspective. Our workflow, our human workflow has always been, you create the branch, implement the feature, open up the pull request, maybe mark it as a draft. But in this agentic mode, just create the pull request even before there's any work, almost like planting a flag or a stake in the sand. So you can use that to document, for example, the prompt and other things. I like it. I like it. I hadn't thought of doing it that way. And it also communicates that this work has started to other team members or agents.
Cool part is too is you can't approve your own PR. This knows that you started it, so you can't
Oh,
approve.
oh, really?
I mean,
Okay.
that's kind of critical, but
Yeah, make me root doesn't work. All right. All right. Well, thanks for that quick tour. Any questions on this from anyone? Yeah, and now we're having battle bots with Mergify. So this is related to our own Mergify configuration, not taking into account the Copilot workflow. Thing is, I bet we could ask it now in our Mergify configuration to fix that. If we go over to Cloud Posse, GitHub, Cloud Posse.github, I bet we can now just go to our Mergeify configuration. What was the message, Ben? Do you remember? No changes. No change. Yeah. Has no changes. Yeah, so file 0. So I bet we can now just ask this to add an exclusion for the copilot agent. Yeah. Oh, but I can't because it's going to close it. All right. So once we implement this, then it'll work. All right.
The one last manual code change.
Yeah. And then I can retire finally. Oh. Next. So, well, this is actually for me now. I love it. Couple of AWS announcements that caught my attention. The fact that these are kind of cool makes me think that, yeah, we're gearing up for AWS reInvent and announcement palooza when you get DOS attacked by AWS announcements. Well, AWS application load balancers finally support native URL and host rewrites, so you don't need to do a Lambda for that. And it can do that on the fly without a redirect or anything like that. This is how many have had to hack together maybe an Nginx proxy or something else. Not sure how advanced it is, though. For example, if it can take into account other conditions. Okay. Next announcement was immediate clones of EBS volumes. So you don't need to explicitly snapshot, wait for the snapshot, restore the snapshot as a volume. Apparently, based on my understanding of what they're saying here, you can just literally clone a running EBS volume. For example, for preview environments or dev workflows or other things like that. Now, it'd be pretty cool if they did that for RDS as well, I guess. So you could basically do branching of RDS clusters, but not with 45-minute spin-up times. Like I'm thinking Neon, like how you can get instantaneous branches. That'd be really cool. That's what RDS needs.
Single-digit millisecond latency. Interesting. Wonder how they do that.
Yeah, so this is interesting. Maybe this is building up to a feature for RDS because presumably RDS supports or uses EBS under the hood, and maybe at reInvent they'll be announcing therefore this instantaneous branching of RDS databases. That'd be freaking sweet.
And a time machine for RDS databases.
Yeah. What a time machine? I mean, I get it conceptually, but
they have it now for DynamoDB. Like you can just instantly change the DynamoDB that has that turned on to go back into a particular point in time.
Oh, and what's and it's basically instantaneous, you're saying?
The point in time feature for DynamoDB, I believe so.
Yeah.
Yeah.
Okay. Wow. That's cool.
I mean, it's like a log structured file system or log structured block storage system.
Yeah, so going to back to that point in the journal.
Yep.
Like that's built into Neon, for example, and we used that when we broke a database last week.
That's great. First-hand experience. All right, and then just another reminder, since I know not everyone attends all of our office hours, we did announce last week that we have a new feature. We're going to demo that on the call today called Atmos Auth. Atmos Auth is a new way to handle authentication for team environments, essentially. When you're using Google Cloud, AWS, Azure, etc. inevitably you have a lot of IAM roles and identities, and the current industry standard is basically go to this wiki page and copy these settings and configure it locally, when everyone on the team could just share from a shared configuration of how those identities are managed. Tools like Terraform have some concept of this, but once you go beyond like a single Teralith, or you have a lot of Terraform root modules, then you probably need to manage this in some more intelligent manner. Also, what if you're not just using Terraform? What if you're using Packer? Or what if you're using the AWS CLI or other homegrown tools or anything else? All of those need identities when you're working with cloud services. So we built this into Atmos. You can use Atmos Auth without needing to use everything Atmos provides. You can use Atmos Auth and immediately get this benefit. Now, it's a foothold into the door, or to use the other things that we provide in Atmos. And we plan to have a tutorial on how to adopt current environments into Atmos. The PR is open for it, but I haven't gotten to finalize it yet. So Atmos Auth, we're going to be demoing that just here shortly. Ben's going to show that. The other thing we added was for Atmos described component, we added a new provenance flag. Provenance lets you see exactly where any line of configuration came from in Atmos. So the power feature of Atmos is it supports this concept of imports, where you can import one config into another config, and that config can import other configs. So you can make configuration very dry. But with super dry configuration, you get what we call complexity rashes. And with a complexity rash, you really don't know even where sometimes the setting comes from because things are so dry. Now, first thing we advise is let's not make things so dry. Second thing is if you want to figure out where something comes from, now use the Atmos describe component and pass the provenance flag to find out. All right, so Ben, you ready? Let's do a demo.
Yeah, let's do it. So
Stop sharing here. Ben's going to take over.
all right, so let me open up the docs. All right, so as Eric was saying, the reason we sort of started to develop this feature is Leap has been great. It worked really well for us to authenticate. There's a ton of ways to authenticate to AWS, but Leap was one of the ones that stuck around for a long time. It had a lot of really nice features from a developer experience. So unfortunately, Leap is slowly being deprecated. The tool is still out there and exists and is open sourced, but it's archived, which means no more features, and it'll slowly, dissolve. So we built Atmos Auth to essentially start to replace Leap, but then also we want to be able to expand its functionality. Um, and the reason we really built it into Atmos is to avoid tool fatigue. So rather than having AWS Vault or whatever the different tools are to authenticate, let's build it into Atmos. We can tightly integrate it with stacks, the Terraform commands, Packer commands, whatever you want. Um, and so from there, we developed this architecture that I'm about to show, so that you can authenticate to AWS and eventually other providers and identities. Um, yeah, so let's get into some of the Atmos Auth stuff that you'll see. So we're gonna I'm gonna show you some of the configs that we use with CP Live, which is one of our internal infrastructures. These are the various commands you can run. A lot of them are pretty self-explanatory. Validate your auth config. Log in will refresh your credentials and make sure you're signed into whatever identity you specify. Auth environment. This allows you to essentially export your environment variables so that you can use the authentication with some other shell. One of the use cases here is geodesic. And then there's Atmos Auth exec. This is the typical command of I just need to run a simple command in a certain identity or a specific account. So the use case here is like, I'm authenticated to our identity account, and I need to list all the buckets or do something in the dev account. Atmos Auth exec will help with that. Finally, Atmos Auth, who am I? Just a debug command to help you understand what's your current identity status. Okay, so with that, let me move my Zoom window.
Any questions before we move on?
And all of this is if you just run Atmos Auth, you'll need to run a subcommand. So these are all those. Atmos Auth was released in 1.194. Recommend using 1.194.1. It has a small bug fix. And so let's get into the configuration of what your atmos.yaml will look like. So Atmos Auth is configured in your atmos.yaml mostly. It also can be overridden in stack configurations. We'll get into that. So the main things you need are providers and identities. So a provider is your initial source of credentials. It's the starting point in the chain of identity. The ones we support out of the box are right now AWS SSO, AWS SAML, GitHub OIDC, and then there's a niche use case for AWS users. But those are actually identities. So then you have the identities. The identities are like either chained roles, permission sets, or assumed roles and users. So those are who you're signing in as, and providers are what you're signing in through. All right, so coming down a little bit more, here's the different examples or the different providers and identities we have. And you can chain them. So you can have any depth of chaining. So you can sign into SSO, sign into a permission set, assume a role, and then assume however many other roles you want. And then the last one on the chain is the one that you're going to authenticate to before running any Terraform commands, which is the typical use case we found. So the other thing to note that we wanted to add from Leap that was really nice because if you're running a Terraform plan on something like an EKS cluster, sometimes that can take up to, I think, 40 minutes or so. Leap will refresh your credentials. This will do the same, and it'll refresh it before you even start to plan. So yeah, what we do is as you run a Terraform plan, we check what credentials you have. We navigate up the chain of identities that you've specified, and then we'll authenticate at the earliest one that we find that has valid credentials, assuming it has credentials long enough for whatever you're trying to plan. Okay, so you're kind of seeing some of the identities examples here. I think if you want to get started, this configuration example is probably one of the most helpful things to look at. This has one of our PRs didn't update the docs yet, but there's a PR coming for this. This is account ID. This should be a name of the account. But if you want to get started with auth yourself, these configuration examples have AWS SSO with permission sets, SAML, GitHub OIDC, and if you want to use an AWS user. But I'm going to go into this right now using our live configuration. Okay. Is my
Can you make it a little bigger, Ben?
just what I was about to ask. Was it appearance? Oh, I'm so used to JetBrains. I haven't done this in Windsurf yet.
You just hit Command plus, right?
Yeah, okay, perfect.
That's good.
All right. Okay, it used to not work for me. So here's our atmos.yaml. You'll see I have log level debug. Obviously, I'm setting my log level to debug. This is only for auth specific things. And it'll return to whatever your default atmos.yaml is, logs level for the rest of the commands. So if your Terraform debug level is, or Terraform log level is info, you can set auth to debug, and then it'll return to info level later. Here you'll see we have two different providers, our SAML role, or our SAML provider, and our SSO provider. These are pretty standard configurations. You just specify the kind and then whatever details are required for that specific provider. For SSO, we just have the start URL. which is great. Coming into identities, we have one super user here. This is just a AWS user that we sometimes sign into. I'll show you how you can authenticate with this in a bit. So the typical use case we find, or that we use, is a permission set called Identity Manager's Team Access. This is something that we provision via Terraform, our component AWS Teams and Team Roles. So the AWS Teams creates this manager's team access permission set in SSO that then assumes a role. And then from there, we have access to a bunch of other roles in every account. And that's how we kind of manage our architecture here. So I'm going to run let's see, Atmos Auth login identity is this one. Tab completion will come. Okay, so this went to our CP Live SSO login, which is using Google. I'm already signed into Google, so I just have to allow this. Perfect. So now Zoom's in my way again. Okay, so this says I'm signed in and I'm pretty much ready to go. So I'm gonna run Atmos Terraform plan, the VPC component in the Plat UE2 sandbox account. So if we come to our stacks here, you'll see here's the VPC component that I'm planning. I am in the Plat US East 2 sandbox account or stack. And you'll see here I have this auth component override. What this is doing is saying this is actually merging in to our atmos.yaml. This is where you can specify overrides for stacks. So we have this idea of a default identity. If you don't have a default identity, we'll prompt you for it, unless it's CI, in which case it'll just fail. But what this is doing here is saying for the VPC stack specifically, I want to set my manager's team access to be my default profile or my default identity. So Atmos Auth will authenticate to it and then run the Terraform plan for this component. And this was the one I just logged into. So what we expect is that nothing happens. It just starts running Terraform plan. And that's because I just ran the Atmos Auth login command before, so it found valid credentials. So as you'll see here in the debug logs, it found the default identity we're trying to use. And then coming into the Atmos debug logs, you'll see we have valid credentials already found, so we're skipping. We navigated the chain, which is, I want to use this permission set called manager's team access in the core identity account. And that's, again, that's this profile, or this identity, sorry. And it gets its source credentials from the CP Live SSO provider, which is a AWS SSO login. So then you'll see here, these are some of the environment variables that we're overriding for this specific permission set. So when you use an AWS identity, we override the AWS config file, profile, and shared credentials. These are managed in your .aws directory, similar to normal AWS config, but it's in a subfolder called Atmos. So we're not messing with your default AWS config or credentials. It's named based on your provider name. So in this case, CP Live SSO, and then your profile name is based on your identity's key. All right, so then what's happening is we go through typical Terraform plan. So I want
to take a break there, or pause there for a moment. And this was something that in our design we came up with a little bit later regarding how we are using different configs and credential files as it relates to AWS. I think this is a really smart thing that isn't something most people would practice by default. So if you think about our situation, we work with multiple clients. We could be possibly signed into multiple clients at the same time. If you're using the standard conventions, you're using one AWS config, one credentials file, and you're logging into production here, dev there, this client here, this client there, etc. You have this permission scope of everything accessible at any given time. And that seemed like a risk and a liability. And if you also want to just delete all the config for just one identity or one provider. That was cumbersome. So what we did deliberately here was namespace the AWS config and credential files by your provider, such that it makes logging in and logging out easy. You're never accidentally having access to a given a certain permission scope that you weren't intending to. And it's not messing with any manually configured AWS config that you have personally, maybe for your home lab projects and so forth. I think this is a really important part. Any questions on how we're using AWS config and why we namespaced it? The other really nice thing with this is Ben can do a screen share here, and he's not leaking anything sensitive with anyone because there's nothing sensitive for anyone. The metadata information that we have in the config here is not considered sensitive or secret.
And this keyless authentication, this is with OpenID Connect, isn't it? OIDC.
Well, that's one of the methods it supports. So, for example, you can then use Atmos Auth. Well, one of the challenges, right, is that you need certain identity when you're running it locally as a human, and you need another identity when you're running it in CI. The CI identity would be OIDC, and then you can configure CI to use that identity without needing to change your Terraform or the commands that get called by Atmos. Do we have an example there?
I don't. I have docs, and that's the best I can show right now.
Okay.
That looks really good, and especially thinking ahead for the AWS user break glass. Really nice.
Yeah. So this is a break glass scenario.
This is actually really cool. I do want to show that. You can use the templating, but there's another way too, which I'll show. So if we look at the AWS config and credentials, those only store the depending on how you look at the chain of identities, it only stores the rightmost or the last identity that you're chaining into, which in this case is the permission set. And I'm sorry about the React emoji. That's there was no Terraform one. So your AWS config and credentials stores the permission set. But what we wanted to do is store your login steps along the way so that you don't have to keep authenticating with Leap. And so that's where your keychain comes in. Keychain, we found I think it's Go keyring. It's a Go library that allows us to write to the keychain for Mac, and then I forget what it's called in Windows and Linux, but the equivalent essentially. So as you log in and chain down the identity chain, we store the credentials in your keychain so that as one permission expires, we navigate up and are able to re-authenticate down back to whatever identity you're trying to use at that time. So the other thing that allows us to do is run the other command here, configure user. So this is that AWS user thing I was talking about. So you'll see in here, I just have a CP live user defined. So I'm going to run AWS Auth. Whoops, not that. Atmos Auth. It was a configure, user configure. And it's going to say choose your user identity that you want to find or that you want to update, and then asks for access key, secret key, and if you have one, MFA-R. I've already ran that, so I'm not going to do it again, but it does add it to your keychain here. So CP Live super user, that's the identity I had. So now if we go to a stack like account settings that uses our CP Live super user as the default, I can run Atmos Terraform plan, account settings, stack is plat, no, global, sorry. Sandbox. So here you'll see again, we're using a different set of credentials. It's under the AWS user, and that's where we're generating the credentials to now. So this is just going to run and plan through, but the cool part is you can use the environment, where was it? here you can use the environment, which is, if you have your environment variable set to these access keys and secret keys, or you can use the Atmos Auth configure user to write them to your keychain, and then you don't have to have environment set in your bash profile or wherever you put them. Hopefully not there. Okay, so then let's do another example. This is a slightly more in-depth one. This one is chaining roles. So the previous example, VPC auth, what happens here is I signed in to SSO. It kind of was that window that popped up to verify that I'm signed into CP Live SSO. I chose the permission set, which is my identity, and then Atmos Auth stopped and Terraform took over, where our providers.tf, this is typical in a lot of our components. If you take a look at the component, where is it here? Terraform, VPC. In our providers TF, you'll see this block. This is using account map to dynamically choose a role based on the stack you're in. So we sign into the identity account. This provider.tf then says, which role should I assume to get into sandbox account so I can plan the VPC? And that's great. But now that we have Atmos Auth, maybe we can do something different. So if we come to the VPC no provider component, here's my stack config for it. I am pointing at a local Terraform state for now. But I have Plat Sandbox Admin as my default identity now. Coming back here, Plat Sandbox Admin. This is an AWS assumed role from the Core Identity Manager's team access. So I'm going from SSO to a permission set to an assumed role, and this is just the role I'm going to assume. So I'm going to run Atmos Terraform plan VPC no provider. Oh, and to show you what that looks like, my VPC no provider is this, which is pretty simple. And actually, this could actually even be dynamically generated by a stack config, so we wouldn't need a providers.tf anyway.
Pausing there for a moment, one of the use cases here from our perspective in the problem solution cycle has been that we have been very opinionated in a lot of our components about how you get an identity. And in a brownfield environment, in an enterprise environment, there are a lot less assumptions and conventions that we can take for granted. So we needed to still have our Terraform root modules work pretty much anywhere, our components, but we can't have our components so opinionated they also dictate what the IAM roles are and so forth. Those might come from a central security team or IAM team inside of a larger enterprise. So what's nice about these changes from our perspective is supporting the brownfield situation where we can continue to write highly reusable root modules and components that work pretty much in any enterprise context, while allowing the identity and auth layer to sit outside of that as a strict configuration in Atmos.
Yeah, so what happened here is instead of try to write these diagrams today, so they're a little bit wonky, but when we ran Atmos Terraform plan VPC no provider, signed into SSO again, this was cached. We signed into the permission set, and then we then, all of this in blue, which is everything, is in the Atmos Auth chain. So then from the permission set, we assumed role into the sandbox account, which is under one of those roles that we assumed. And then finally, Atmos Auth said, we've reached the end of our identity chain. Let's go have plan Terraform. So that's pretty cool. So the last one to show off is something similar, which it's just using a different provider. And this is SAML. So SAML behind the scenes uses SAML to AWS's Go library that it's built. So SAML to AWS is a pretty typical way to sign into SAML. We utilize that for Atmos Auth if your provider is SAML. So Atmos Terraform.
In the interest of time, though,
Yeah.
it's more or less the same flow.
It is.
We can show something, that's different or stands out, but The SAML flow has been helpful for us when we want fine-grained control over the whole identity architecture in AWS. Most teams use permission sets these days, but permission sets, you can't have multiple identity providers still, I believe, with permission sets. But with SAML, you can have as many identity providers as you want. So you could have, for example, one OU using one identity provider and a different OU using a totally separate identity provider with SAML.
Yeah, that's pretty much it for the demo, at least for now. I know we have more stuff coming in the pipeline, but yeah, so if you want to get started, check out the auth page. We have a lot of configuration examples for at least getting started, and then you can do various identity chaining, and this also goes into some of the details of how does it work, common issues, how do you integrate it, debug mode, which again is just oh, I guess there's one more thing I can show. So we talked about the exec command. This is just one of those simple ones I can run. So we can run Atmos Auth exec. We want to sign into the identity of the sandbox account. And then we want to run AWS S3LS. So all of our buckets are prefixed with our module.dist.id, so we're in the right account. This is the Plat sandbox. So essentially, I just real quickly ran AWS S3LS from signing into SSO, going into the permission set, assuming role into the sandbox account, and here's our buckets. Pretty cool stuff. And then if we want to show the environment, these are the different environments you can, environment variables you could export. So I think it would probably be xargs if you want to just export it onto your current shell. But I guess at that point you could also just run exec. Atmos Auth environment, and then we want to remove that. So this exports it as, by default, it'll do export format. We also support .env file and JSON. So if you want to export these, you could then, pipe that into, what is it, xargs, and set your shell that way. So that's
eval.
Thank you.
Or well, not quite, but close enough.
I forget the exact command off the top of my head, but but you can do that.
Yes.
So then exec is AWS commands, or really whatever you want to run. Login, make sure you're logged into something. User, this is really just to run the configure one. Atmos Auth validate, this validates your atmos.yaml config. The thing this doesn't do necessarily is validate that your stack overrides is valid, because this doesn't take in a component in a stack instance. We'll see. But for now, this just validates your atmos.yaml. And then who am I can show you what you're signed in as. Oops. Sandbox admin. So I'm signed in, and it expires in about 8 hours. So that's all, folks.
Thanks, Ben. That was a great overview. Covered everything. If you have any questions on Atmos Auth, feel free to drop by our Slack community at cloudposse.com or cloudposse.com/Slack. And ask in the Atmos channel there. Also, feel free to join us next week on Office Hours if you have more questions on Atmos Auth. We'll be posting a recording of this video after Office Hours, so you can find that on YouTube. Separately, I wanted to just announce one thing I forgot to say. Next week, we have a special guest, Marcin from Spacelift. He's the founder of Spacelift, one of them. He's going to talk about spacelift-intent. Spacelift is one of the most popular solutions for automating Terraform. We've used them a lot in the past. Spacelift is also one of the largest backers of the Open Tofu initiative, which is managing a free and open version of Terraform under the CNCF. So Spacelift is one of the supporters of that initiative. Spacelift-intent, if you didn't hear about it last week on Office Hours, it's a pretty radical take on infrastructure, and Marcin is gonna break our attempt to break our minds free of how we've been thinking about infrastructure as code, maybe. Spacelift-intent is at github.com spacelift. What was it? Here it is. Spacelift.io, Spacelift-intent. And Spacelift-intent is basically an MCP that speaks the Terraform provider RPC protocol so that it can basically perform any action Terraform can via an MCP. But the kicker here is, like, through whatever method of agentic programming or platform that you're using, which, there's something big here going on. I don't know the full details, so I can't talk about it, but Marcin's gonna bring us in to the know next week. So join us next week for Office Hours to learn more about that. All right, well, we are at time for today. Thanks, everyone. Thanks, Ben, again, for your demo. We'll be posting this recording to youtube.com/cloudposse, so go there to find the recording. If you're ever in need of some extra support, Cloud Posse provides commercial support for our entire open source ecosystem. Just as you're familiar working with, Red Hat for enterprise support on Red Hat products, well, we do that for Cloud Posse. So go to cloudposse.com/support and see if there's some way we can help you out. If you want to get more involved with what we are up to here at Cloud Posse, make sure to first register for our weekly office hours. Go to cloudposse.com/office hours to register. Just enter in your email. You'll get an invitation from our Google group. Subscribe to our YouTube channel to get these updates. We are always announcing new things happening at Cloud Posse, updates to Atmos, so it's a great way to stay in the loop. Join our Slack community. Our Slack community is open to anyone to join. Just go to cloudposse.com/Slack. And you can also register for our newsletter at cloudposse.com/newsletter. See you all next week, same time, same place. And looking forward to that Spacelift-intent presentation. Take care.